Hello guys, how are you today? So today I'll be explaining the math course practice of section 4.2. It's only 5 questions, so I'm gonna try my best to finish it like as good and explaining as possible and as fast as possible. So the position of a particle moving along the x-axis is given by this. So this is what? This is the equation of position, right? Where x is in meters and t is in seconds, the velocity at time 2, so they did not tell us it's velocity at a specific interval. They did not tell us it's average velocity, they told us velocity at a specific time, so this is instantaneous velocity. How do we find instantaneous velocity? Very simply, we take the derivative, so it's gonna be 4t to the power of 3 minus 6t. Now what do? We substitute 2 in the time, so 4 times 2 to the power of 3 minus 6 times 2. That's gonna give us an answer of 20. So just let me double check. So 4 times 2 to the power of 3 minus 6 times 2, that's gonna be 20. We move on to question number 2. What does it say in question number 2? The displacement of a particle along the x-axis is given by this. So this is the equation of displacement, which is the same as what they mean by position in some cases. So where x is in meters and t is in seconds, they want the average acceleration. How do we find the average acceleration? Perfect, they told us average and not instantaneous. So in order for us to find the average acceleration, we'll need to take velocity 2, subtract it from velocity 1, and put it over the difference in time. So delta v over t, this is from physics. Average acceleration is the change in velocity per time. Right, so what do we do in this scenario? We need to find the two velocities at 3 and 1 second. So we'll need to take the derivative of the displacement to find the velocity. So that's going to be t to the power of 3 minus 16t. So at 1 second, the velocity is 1 to the power of 3 minus 16 times 1. That's going to be minus 15. And at 3 seconds, the velocity is 3 to the power of 3 minus 16 times 3, so that's minus 21. So now what do? We do v2 minus v1 over time 2 minus time 1, so minus 21 minus minus 15 over 3 minus 1. So put it on the calculator, and you will get an answer of minus 3 meters per second squared. We move on to question number 3. What does it say? It says the displacement of a particle moving along the x-axis is given by this. So this is what? This is displacement equation. Where x is in meters and t is in seconds, they want the acceleration at time 2 seconds. So it's not in an interval, it's not average, it's at a specific time. So it's instantaneous acceleration. How do we find that? We need to find the equation of the acceleration, which we can find it by doing the double derivative. So we do the first derivative. It's gonna be after solving, it's gonna be 2t to the power of 5 minus 8t to the power of 3. This is the first derivative, the equation of the velocity. Then we do derivative again to get 10t minus 10t to the power of 4 minus 24t squared. Okay, so this is now what? This is the equation for acceleration. Now what do we need to do? We need to find acceleration at 2 seconds, so we substitute t by 2. So it's gonna be 10 times 2 to the power of 4 minus 24 times 2 squared. So that's gonna give us an answer of 64 meters per second squared. We move on to question number 4. What does it say? It says the position of a particle moving along the x-axis is given by this. Where x is in meters and t is in seconds, the particle is at the origin. What does it mean at the origin? That means that the position is 0. So at the origin means that the position is 0. So what are we gonna need to do? We're gonna need to take this, right? So 0 is equal to 3t minus 15. Move this to the other side. 3t is equal to 15. T is 5 seconds. Okay? We move on to question number 5. The position of a particle moving along the x-axis is denoted by this. They want when the particle is at rest. So when the particle is at rest, this means that velocity is equal to 0. So what we're gonna need to do is we're gonna need to find the equation of velocity by taking the derivative, so 6t minus 12, and we'll make it equal to 0. So 6t is equal to 12, t is equal to 2 seconds. That means the time is what? The time is 2 seconds. Let's submit, and hopefully we don't have any mistakes. Perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.